All right, so in 10.6 we learned about if two chords intersect, what happens to their length, if two secants meet at the same point, secant segments meet at the same point outside the circle, and if a secant and a tangent meet at the same point outside the circle. This is the case of which one? Two chords. So if the two chords intersect, then the product of their segments equal each other, right? So this would be 20 times x would equal 4 times 10. 20x would equal 40, and x would equal 40 divided by 20, which is 2. Questions on that one? Okay, two chords again. This time I would get x times x plus 1 equals 4 times 18. So x squared plus x equals 72. As soon as you get there, you know you're going to factor, right? X squared plus x, subtract the 72. Factors of x squared are x and x. And then I'm looking for the factors of negative 72 that add up to positive 1, which would be what? Good. Negative 9, positive 8. No, negative 8, positive 9, because you want the bigger one to match that positive sign. Set these each equal to 0, and then when you solve it, you get positive 8, negative 9, and since one of our lengths can't be negative, we rule out the 9 and keep the 8. So I think I mentioned it yesterday, but I have like a video that goes through all the different types of factoring. So if you know that you need a little bit of a review, it's on the YouTube channel, okay? It just goes through how to approach factoring, how to look at it, how to start, where to go from each different type of factoring. So if you know you're one of the people that need the extra help, it's there. And then your book at the very end of the chapter, after the chapter test, God bless you, in your book has a whole page of it says algebra practice, and it's like, I forgot how many questions it is, it's a ton of factoring. So if you need the extra practice, it's there. All right, 3. This is what? God bless you. What kind of segments? This would be a tangent and a secant. So this is where we would say that the tangent squared equals the whole secant segment times the external part of this secant segment. Or x squared, which is the tangent, would equal the whole. So what's the whole length of the secant? 25 times the external part, which is, God bless you, 9. 25 times 9 is 225. And then the square root. Okay, if you don't know it, then divide by 5, or 25 even, right? We just said that this is 9 and 25. This would be 5 and 5. This would be 3 and 3. You can take out a 3 and you can take out a 5. Questions on that one? Okay, this is what? 2 types of segments. 2 secants. So this is whole times external equals whole times external. So the whole here is this whole segment, which is 40. The external part is the x. The whole secant segment here is 45 times the external part, which is 18. So I get 40x equals 810. Divide both sides by 40. X would equal 810 over 40. I can cross through the zeros. And then I would say 81 over 4, or 20 1/4. So it says round to the nearest tenth. You're not going to have a calculator, so make sure you don't use the habit of like taking that and dividing it. You can write it as 20.25 if you'd prefer that over the 1/4. But if it's a radical, you're going to leave it in terms of the radical. Questions on that one? And then the last one, find the value of x and round to the nearest tenth. So we're back to 2 chords. So this would be x times x equals 8 times 16. Where x squared equals, now I could multiply this out, right? I could get 128. But then I'm going to end up square rooting it again anyways. Square root of 128, when I break down, I can go back to the 8 and 16. And then I can go back to 2 and 4, 2 and 2, 4 and 4, 2, 2, 2, 2. And then for each pair of 2s, that's 1, that's 2, that's 3, and there's 1 left over. So I'd get 8 square root 2. Questions on those? Raise your hand if you got all 5 right. 4 out of 5? Okay, not bad. Okay, so for 7 and 8, 7, you're going to do, this is 2 secants, whole times external equals whole times external. So the whole on the top is 12, 12 times the external part, which is 5, and the whole here, which is x plus 4, times the external part, which is x. So this is 60 equals x squared plus 4x. And then again, as soon as you see that there's a squared term and a non-squared term, you're going to want to get everything to one side. So 0 equals x squared plus 4x minus 60. The fact that it's a minus 60 tells me there's going to be 1 plus and 1 minus. The plus in the middle tells me that the larger one's going to be positive, but I want them to be 4 apart. So what 2 numbers multiply together to give you 60 and negative 60, sorry. And when you add them, you get 4. Fernando. Negative 6, positive 10. Set them each equal to 0. X is 6 and x is negative 10. And then we rule out the negative and keep the positive 6. Okay, number 8 is the same. This is 2 secants. Okay, this is 9. So this would be 9 times the external, which is 4, equals, this time you've got 2 binomials. So if I add them, x minus 2 plus x plus 4, I end up with 2x plus 2 as my whole. And then the external is x minus 2. So some additional factoring, not factoring, algebra review, that we've got to FOIL that out. So this would be 36 equals 2x squared, negative 4x, positive 2x, negative 4. And then combine your like terms. And move the 36 on the side with the rest of it. So one of the first things you want to look at when you are factoring to make it easier on yourself is, can I take something out? So is there something that all 3 of those terms are divisible by? 2. So if I take it out, I get 0 equals 2 times x squared minus x minus 20. And then if I were to continue to solve this, I would have divided both sides of the equation by 2. 0 divided by anything is what? 0. So that 2 goes away, and now I can factor that right side. So what are the factors of negative 20 that add up to negative 1? Emily? Negative 5, positive 4. And then set them each equal to 0. Rule out the negative. Keep the positive. Questions on that one? Okay, and then 18 says to find PQ. So before I can even do, like this is a right triangle, the large triangle is a right triangle. I could use the Pythagorean theorem, but I have to find QR. So if you focus first on QR and RS, that's a tangent and a secant. So the tangent squared, let's say this is x, x squared would equal the whole thing here, which is 26, times the external part, which is 14. So 20, actually I don't even need to multiply that out because I get x equals the square root of 26 times 14, and I can break that down if I want to, or I could multiply this out. So this would be 104, 624, 364. Just the side on the top. Now that's not my answer, so I don't need to simplify it. I can keep it the way that it is. And then I want to use the big triangle. So x squared, which is square root 364 squared, plus PQ, let's call this y so don't confuse our variables, y squared equals 26 squared. 26 times 26. 676. Square root of 364 squared would be 364 plus y squared equals 676. And then subtract And y would equal the square root of 312, which they actually figured out what that is, but you want to leave it. So this would be 2, 156, 2, 78, 2, 39, 3, and 13. So it's going to stay as there's one pair of 2's, 2 root 78. Evan.
That's how you want us to write it.
Yeah, so on your test you won't have your calculator. So you want to get in the practice of if it's a square root. I don't know if you'll get a question like that on your test, but if you did, if there's a square root in the answer, then you want to make sure that it's simplified, but you leave it as the square root. Questions overall on any of 10.6? Okay, so last section in the chapter, okay, this is writing and graphing equations of circles. So this is a little different. This puts you back in the coordinate plane, okay? Funny thing about this is I've actually taught this exact same lesson in Algebra 2. So in 365 days, if you're in regular Algebra 2, you will get this back again. And then you can be geniuses that already know it.
You teach regular Algebra 2?
I am right now, yeah. When you start with a circle that has a center at 0, 0, and the radius is length r, the equation is x squared plus y squared equals r squared. So if I told you that r was 3 and the center's at 0, 0, the equation would be x squared plus y squared equals 9. Just have to square the radius. So this says write the equation of the circle shown. Where's your center? 0, 0. What's your radius? 5, right? From the center to any of the 4 corners. So you can go north, south, east, west. You want to count directly up, to the right, down, or left. Either way, because radii are all the same, you should count 5. So x squared plus y squared equals 5 squared. And then just take it to the next step. X squared plus y squared equals 25. Okay, obviously what could change is your radius. So all of these have the same center. All of these have the same center, which means the left side is going to equal the same. The difference will be the right side of your equation. God bless you. So for A, my answer would be what? Equals 4 squared or 16. B, x squared plus y squared. 5. Square root of 5 squared is just 5. And then there's a little bit more work involved with the last one. X squared plus y squared equals 4 root 3 squared. So when I've got two numbers being squared, or in this case a radical and a number being squared, this is the same thing as saying 4 squared times the square root of 3 squared, which is 16 times 3, or 48. Changes is that you're not just saying x squared and y squared. You say x minus the x coordinate of the center plus y minus the y coordinate of the center. Each of those squared would typically, if I'm finding distance, it would be underneath the square root. So to get rid of that square root, you just have to square both sides, and you end up with the standard equation if the center is not at 0, 0. So it's x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. So same type of question. What's different here is that the center is now moved. So it says write the standard equation of a circle with a given center and radius. So the first one, if this is my h and this is my k, and it's x minus h squared plus y minus k squared equals the radius squared. Then A would be x minus 1 squared plus y minus 2 squared equals 4 squared, which is 16. Nope, you're just finding the equation. That's it.
How do you know whether to use the one that has the square root and the one?
You'll never use the one. The square root is how you get to this one. So this is the standard equation for the circle. You'll always use that one. So then B, Now my center is at negative 3. So if I have x minus a negative 3, what happens? It becomes plus. And then y minus 5 equals the square root of 5 squared, which is 5. And then the last one, x minus 0 squared plus y minus a negative 2 becomes plus 2. And then we just did this. What was 4 squared at 3 squared? 48. So this one you'll just go to the next step because you don't need that 0. So this would be x squared plus y plus 2 squared equals 48. So every single point, when you plug it into the equation, is going to end up with the opposite sign, okay? If it's a positive center coordinate, then it becomes negative in the equation. If it's a negative center coordinate, it becomes positive, right? Because if we do minus a negative, it goes to positive, and if we subtract a positive, it's negative. So that you just have to switch those signs. So now you're going to kind of put those two together. The first thing we want to do is figure out what the center and the radius is, and then write the equation. So in A, we see the center, right? What's the center for A? 4, 1. What's the radius? If I go up, right, down, or left, my radius would be 1. So then I plug it in. X minus 4 squared plus y minus 1 squared equals 1 squared, which is 1. Okay, what's the center? Negative 5, 3. What's the radius? 3. So x, the equation x plus 5 squared, go ahead, Matt. Plus
Y minus 3.
equals? Nope.
9.
9, good. Easy stuff, right? Okay, the last thing is just going in the reverse. So now you're given the equation and you've got to find the actual graph. All right, so look at A. Now we're taking it back out. So if when we had the initial point, we plugged it into the equation, it changed its sign. What do you think happens when we take it out of the equation? Changes it back. So the center for A should be what? 3, negative 1. And if we square the radius to get to the equation, how do I find the radius? Square root it. So square root of 4 would be 2. So I go to my center, which is 3, negative 1. I plot a point. I count to the right 2. I count up 2. I count left 2. And I count down 2. And I draw my circle. Don't worry, I won't judge you on your circles because mine are not good. Yeah.
Wait, how did you do like the 2 things?
So what's the center for B? Negative 2, 0. And the radius? 2. So negative 2, 0. And then I go right 2, up 2, left 2, down 2. Questions? Does it feel good to end the chapter on an easy section? Yes. Yeah.